Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Shubham. Hi Shubham, tell us a few words about yourself and about the tool you want to show us.
Hey, Alexey, thank you so much. Really excited to be here. I work for a company called Tabsdata. I manage product and operations there. Tabsdata is an open source platform to enable PubSub for tables architecture. And let me take a moment to explain what we mean by PubSub for tables. Uh, Basically, in this architecture, the data producers and consumers within an organization exchange data by publishing and subscribing to entire tables. This is unlike the existing ways in which the data and information gets exchanged between data producers and consumers, where you have direct mapping and pipelines running between these stakeholders. In PubSub's tables architecture, you have entire tables that are getting published by the data producers, and then these tables are then subscribed to by the data consumers within an organization. Tabsdata in this enables the publishing, subscribing, and storage of these entire tables, which is the core of the PubSub for tables architecture. Um, Along with enabling the core, Tabsdata also has another extended features like built-in connectors, lineage, provenance, and many more features that help take PubSub for tables architecture to the next level.
I'm just thinking about a use case. So let's say I work in the data science team. So my background is data science. So I work in the data science team. Let's say we want to build a model for churn prediction. And there is another team that is creating events for that I might be interested in, like all the actions that users make on the platform. So if I want to make a model for churn prediction and I'm interested in all this data, and the team who is producing this data, they can publish this table and say, okay, this is the table and this is a new table. You can subscribe to the data from this table, right? Or how exactly it works?
Yes, exactly. Yeah. So it has two advantages, right? So on the data producer side, this table may not just be consumed by you, but many other people in the organization. So they just publish that table. It exists inside the Tabsdata system, and you can so if you go and ask them for that particular table, they will just be like, okay, here it is in the Tabsdata system. Here is the URL. Just go and subscribe to it. That is, and that's something that they can do for many other people. For you, it becomes easier because uh, if you want to have multiple such tables that you need to interact with, instead of creating pipelines or establishing one-to-one mapping with different data producers, you can just connect with Tabsdata and all the tables can be taken directly from Tabsdata for your use case.
And that sounds interesting. I'd love to see the demo.
Sure. Awesome. So let me just share my screen. Yeah, before we get in the demo, just one brief walkthrough of what we'll be doing. So we'll have a customers.csv that exists in our local storage. We'll be publishing this to the Tabsdata system. In Tabsdata, we have things and data structured as collections. So we'll be publishing inside the customer select collection as a customer leads table. And then this leads table will then be subscribed to within again the local storage system as a customer leads.json. This is the flow that we'll be going through in our demo. Sure. So let's dive right in. I will be using the tutorial one that we have in our documentation, docs.tabsdata.com. And there you can either follow through this tutorial while watching the video, or you can follow through with it later. So we'll start. I already have created a virtual environment test tutorials in my system. You can use your own virtual environment or have it directly installed in the system. So let's just first install the Tabsdata. We have Python client that we use to interact with the server of Tabsdata. Wherever you are going to have Tabsdata installed, you will first be installing the Python library that we have to work with the system. So we'll start the server now. It will take a moment to set up everything. The server has started. It exists in my local. We'll check the status to ensure that the server is started. The supervisor is active, but the API server also needs to be active. Yes, so supervisor and API server both are active now. So now the system The server has been started, it has been set up. Now let's just log into the server. The password is Tabsdata, login has been successful. Now I already have a GitHub repo for this particular tutorial that I'll be copying to my system. In this right now, I have my test tutorials as the folder where I'll be copying the GitHub repo. Just give me a moment. Yeah, so the repo is here now. We will then be having these commands just to set up our environment variable that we'll be using in our Python code, which needs the path to the file. So this TDX is the environment variable that I'll be using in my Python code to refer to where exactly in my local does this file that we'll be working with exists. So you can choose your own way of managing this. This is just my suggested way or the way that I'll be following. So the system is set up, the file and folder structure and the environment variable and everything is set up now. Let me just walk you through the files that we have in this particular folder that we'll be working with. So we have T1 CSV pubsub, which basically means the tutorial one will be working with the CSV, which we'll be publishing and subscribing to. We have the assets folder, which is basically the images that we have used in the README file. And then we have the input folder where we have two files, customer CSV and customers2.csv. Let me show you what the data is inside this. So in the customer CSV, we have this various columns, first name, last name, company name, etc. of customers for this particular demo organization. Then we have similar file customers2, which has the same folders, but there are some additional customers that exist in this file, which we'll see why is it important later on in the tutorial. Along with input, now we have this publisher and subscriber. These are Python files where the code for our publisher and subscriber exists. And we'll go through these code and what does these functions do later in the tutorial. So now that we have gone through the files and folders, we are ready to publish the input CSV as a table to the Tabsdata system. For that, as I had initially shown in the walkthrough, of what we'll be doing, we'll first start by creating a collection where the tables and functions inside the Tabsdata are going to exist. Think of it like a logical container, which is kind of a representation of the domains within an organization. So you have a collection for sales, marketing, finance, and in this case, I'm creating a collection for customers. CD collection create customers. So the customers collection has been created successfully. Let's just verify once if this has been created. The output matches. So the collection called customers has been created. Now we would be registering this particular publisher code that we have in our Python file to this collection. What that means is right now this code of publisher exists in our local system and we need it to exist in the Tabsdata server. And that's why first we'll be registering it. Let me walk you through what is the code and then we'll register that particular function. So we are importing OS, we are importing Tabsdata, and then we are creating a publisher called publish customers, which takes an input table frame, selects certain columns from that particular table frame, and returns the output. Now, table frame is basically a derivative of data frame in the Tabsdata context, and that's why we call it table frame. So you have now, how do we define what the input and output is going to be? This is the function. So for defining the input and output, we use the decorator. So here we have the publisher decorator where we define the source. So the source is the local file and where we have this particular path that we stored initially in the environment variable TDX, the input folder, and inside the input folder, we have customers.csv file. So as you see in the input folder, we had seen the customers.csv file. This is the one that the publisher will be using as the source. The output after selecting the columns is going to be stored in the Tabsdata system as customer leads. This is the name of the table, which is going to be the output of this publisher. So yeah, so that's what a publisher code is doing. It is taking a table frame, which is the CSV file, selecting certain columns from it, and then returning the output as the customer leads table to the Tabsdata system. Now, with the code out of the way, let's register this particular function to the collection customers that we had created. So in this particular command, we had Tabsdata function register. registered it with collection customers, and this is the function path. So the function path is tdx, which is the environment variable we stored, and the publisher.py is the name of the file where the code exists, and publish customers is the name of the publisher that will be registering. So this is your CLI command to register a function to a particular collection. Now let's see if this particular function has been registered. Yes, we can see a function list collection customers. This publish customers now exist inside this collection. Once the function has been registered, we need to trigger it. It's almost equivalent to running the Python function that we do in our local. So we trigger this particular function in the customers collection. So we say td function trigger collection in the collection customers, trigger the function which is named publish customers. So that's what this command does. We need to execute this command to understand whether the function has finished executing or not. So the status is still running. For the first time around, it takes a moment to execute. This is because the system is setting up all the relevant libraries for it to execute the functions. But once it's done, then it will not take as much time for the subsequent runs of functions. Awesome. So the status is published. The publisher has stopped running and has been run successfully. So the table that we were expecting customer lead should now exist in the customers collection. So let's see if that actually happens. So we'll check the table schema. So we are checking the schema for customer leads table inside the collection customers. And we see that the columns that we had selected are the ones that are visible in the schema. First name, last name, company name, email, and website. We also added two initial columns from Tabsdata, the ID and source. This basically allows for detailed lineage and provenance at row level, which enables you to see where the data has come from and where is it going. Now we can also check the samples, and there is full list of CLI commands that is there in the documentation, and you can explore what all things you can do there. Awesome. So now this table exists inside Tabsdata. Anyone comes to you, asks for the customers table, you just point them to this particular collection, you tell them this is the name of the table, and they can go and subscribe to it directly. You don't have to repeat the effort every time there is a new request. Now let's see what happens when someone needs to subscribe to a particular table. So it is a similar method, but instead of having a publisher, we'll be registering a subscriber. So let's first go through what the subscriber code is. So we had a publisher.py. Let's go to subscriber.py. Subscriber code is much simpler than the publisher code. So you have a subscriber called subscribe customers. It takes an input table frame and returns it directly without any modification. Here, how do we define the input and output? Similar to the case of a publisher, here the input is the Tabsdata table, which is the customer leads table that we created using the publisher. And the output is now the destination. Initially in the publisher case, we had the source. So the destination, and then you had local file destination because it will be stored in the local file system. This is the name, this is the path of the file. It refers to TDX, and then you have the output folder where we'll be creating a file called customerleads.jsonl. This JSONL can be anything else, CSV or any other extensions that we currently support for you to send an output to the system. So this is your subscriber code. Now with that, let's register this particular function to the customers collection. It's the same thing that we did for the publisher. We're registering collection to the collection customers, a function called subscribe customers that exists in the subscriber.py file. Let's see if this function now exists in the collection. It does. We had published customers, and now we also have subscribe customers. Let's now trigger this. This function exists. Now, important thing to note is in this particular folder, we don't have the output folder here. So once we trigger this function, we expect the output folder to get created and the customer leads.json list file to exist in that particular output folder. So let's trigger the function and see if that actually happens. We have triggered the function. Now we can see that there is an output folder and there is customer leads JSONL file that exists. So we have Peter, Octavio, Martha, the first three people, and if you go to the customer CSV, these are the first three people that is there in the CSV file as well. And the columns that we selected, first name, last name, company name, email, and web, the only 5 columns that we selected are visible in the output. So that completes your publisher and subscriber. There is one last step that we would want to do. So let's say there is someone within an organization that comes to you that there is an update in the customers.csv. I need to see the updated data. And also, as someone who is the custodian of the data, you would want everyone within an organization to look at the most updated and a single source of truth. And that is what we are able to enable using Tabsdata as well. So in customers.csv, if you remember, we had some additional customers that were not present in customers CSV. So what we are going to do is we are going to copy over customers2 and rename it to customer CSV, so that our customer CSV, which is the input that the publisher file is taking, is then going to act as the new input file with the additional 20 customers. So let's just simulate that. So let's copy the customer CSV file and rename it to customer CSV. Now our customer CSV should have additional 20 customers. So it was, before it was starting from Peter, now it is starting from Alicia. We can also have a copy of our customer leads so that we can refer to the file if the new customers have been added or not. So this customers lead one JSON has been created to have a reference for what the previous version was. Now let's just trigger the publisher. So you, as a data engineer who is the custodian of customers data, there is a new version that is available. You say that, okay, now this new version is available. Let me publish this to Tabsdata. So once you publish this, your output is going to get automatically updated. So everyone who is subscribing to the table is going to look at the same source of truth. So we have it triggered, and customer leads now has the new 20 customers that were not present initially in this particular file, as you can see here. And that's it. That's our demo. We have successfully created a publisher, created a subscriber, and updated the tables if there was a information update in the customers.csv. That's it.
Yeah, amazing. Thank you. And if somebody wants to take a look at the code, see how it works, and then eventually help you with something and contribute, make a contribution, well, how do they go about that?
We have a GitHub repo, so github.com/tabsdata. You can go there. We also have detailed contribution guidelines there, so that can help you get started. You just get the open source version, put it in your system, and then you are ready and good to go if you want to contribute. We also have a Discord channel. We'll also be launching a Slack channel soon. So there you can go and have conversations or any doubts that you may have on how to contribute, and if there are any particular suggestions or questions that you may have regarding the library.
And just in case, can you show us how do we find this on GitHub? Like all these links you mentioned, like Discord.
Let me. Okay. Cool. So you had asked. Sure. Yeah. So we can go to github.com/tabsdata. This is where you're going to find all the relevant details. Here you have Tabsdata open source. So just go through there. In that you have the contributing guide. And here you can find all the details. You can also go to our website where you have the community. So in the community, you can just go to Discord and you will be taken to how to enroll and accept invite. You will then be made part of our Discord channel.
And I already saw an answer to the answer to a question I had in my mind. So what is it implemented in? What kind of language you use? And I saw that it's Rust, right? So Python is the wrapper, but internally it's Rust.
Yes.
That's cool. So what are your future plans? So I think you released it quite recently. And by the way, everyone watching this, I see that this project has only 21 star. We need to fix that. So please, everyone go and give a star. But I see that this project is quite recent. So what are your plans?
Yeah, so we are constantly adding new connectors to the systems that our users ask for. So we encourage you to come to the channel, Discord, Slack, and request if there are any new connectors that you have. And apart from that, we are working on security, metadata, and like user interface enhancements on the upcoming quarter. Yeah.
Amazing. So again, thanks for doing this in open source. And last question I have is, do you have any advice to anyone who is watching this?
Um, I think PubSub for tables is definitely worth exploring for your data integration use cases, irrespective of whether you use Tabsdata or implement it on your own. But just as an architecture, I think it's definitely worth looking into.
Amazing. Thanks a lot, Shubham, for making the demo. And it is a great demo. Thanks for making this project open source. Thanks for your time, for joining us today, for doing the demo. And yeah, and everyone, again, please check out the project and give them a star. Thank you.
Thank you so much, Alexey.